Pointers is an interesting concept in C. Whenever we define any variable, maybe character or integer or float, it is stored in the memory. And that memory has an address. The address is stored by pointer variable. So if we want to know the address, we have to define the pointer variable. Using pointer variable, any variable stored at the address can be accessed. So pointer is a variable that represents the starting memory location address of the variable. Why starting is, in case of character it is a single memory location, but in case of integer there are 4 bytes. It is a 4 bytes, or floating for double the size is different. We can know the size by size of operator. Now AND is the operator that is called as address operator, and star is the operator that is called as a value operator. Means whenever any variable is there, then when you say and the variable name, it points to the address, and whenever you say star with the address, it gives the value of variable at that memory location. Pointer variable is always, it stores address. Address is actually a decimal or integer number, decimal or hex. It can be given in any form, whatever way we want. So it is actually integer number, but its data type is not always integer. It is same as the variable which is stored at that address. So if we want to store character at a particular memory location, then the data type of pointer is also character. So to store character, we'll say character and then the name of pointer. To store integer, then we have to say integer as a data type and then name of pointer. To store float, data type is float and then name of pointer. Remember two things to define a pointer. It's one is the data type is same as the data or variable stored at address, and another is whenever a pointer variable name is defined, you have to put a star before it, because star pointer variable name is nothing but the data at that pointer. Now let us consider some example. Suppose value is a variable name. It is an integer and its value is 150. Then it is stored in some memory location. The memory location is called val and the address is and val. Now if we define a pointer, suppose pnt, pointer variable name could be anything, pnt, and then we have to equate this pnt to address of 150. So pnt is equal to and val. Now what happens is and val is address, pnt is also address, but val is the value and star pnt is also value. So and of value gives the address and star of pointer variable gives the value at that address. Now there are certain things which we should know about the pointers. Pointers provide direct memory access, and using pointer we can call function by passing the reference of the arguments. We have already learned functions with called by value. Now we can call by reference also. In case of functions, we know that it can return only a single value, but using pointers we can get 2 or more answers also from the functions. Pointers reduce storage space. How? That we'll see. Then using pointers you can access the array elements also. And mainly the pointers are used in advanced C concepts, dynamic memory allocation, linked list, trees, graphs, etc. also. But pointers are slightly difficult to handle, and if there are any problems or you can say bugs, then it is very much difficult to find out. So use pointers carefully. Now let's see the use of pointers. So we will write certain instructions to understand how the pointers are. First we'll start from the characters. So let us say character k. We will define character k, and we have to define, let's say the character k is capital A is a character, and we have to define a pointer variable for character k. So that is again a character, but we have to use star, and name could be anything, but for convenience let us say pt k. pointer for k variable. Okay. Now we have to equate this ptk is equal to address of k and k. Now address of k, whatever it is equated to ptk. Now we can check by printing that what is the address, what is the value. So let us say printf, say address is. So this address will print. For the address you have to give %u and value is. Value of the character is given as its ASCII code and the character is %c. So %c character, its address, its value and the actual character that will print. Now address can be printed in two ways. One is and k is the address, value is k itself and the character is also k itself. So here we have not used pointer. Just to understand how it acts, let us execute this part of program. So let us build. Let's run. So address is given, value is 65, character is e. Here we have not used the pointer concept. Now let's write similar using the pointer part. Now address is same %u, but this address will be now given by ptk. ptk is pointer of k. Now value is star ptk. So ptk is address, star ptk is value. So let's see how it works. See, I should give actually \n so that it will be convenient to check. See, same address, same value, same character. That means k is same as star ptk and k is same as ptk. Now let's do it for integers also. You can try it. Integer, suppose I, and let us give value some 23 or 234, whatever it is. This is integer. We have to define its pointer also. So pt, let us call it as I. Actually name could be anything, pti. Now we have to define pti is equal to and I. Now exactly similarly we will show the address and the data both. So let's take it this way, Control C, Control. So address is %u, value is, this is not a character here, so this statement is not necessary. Directly we will display the value because it is integer. Now let's do it in different way. Address is this, value is this. Here we will use ptk, pti, and the value is I. So pti is address, I is value. Here let us for a change use and I, and here let us use star pti. So pti is address and I is address, I is value and star pti is also a value. So let's build and run this. backslash n I will put here also, so it will look better. See, the address is this 635627 for character A. It is 6357 56720 for value. So this is the address, this is the value. You can see that there is a difference of 8 because this particular compiler is using 8 bytes. It is for integers. Okay. Now in this way, we can have the address of the characters or integers wherever they are stored. Now let's use it in a different way. We know that if we want to suppose swap the values of two integers or two numbers. Integer a, let us, is equal to 10. Let us say b is equal to 20. Now we will swap these values. So let us print the two values. Printf a equal to %d, b equal to %d, and let's print the values comma a comma b. So a and b values are printed. Now let's swap them. Swap a comma b using a function. So we have to write a function to swap them. After swapping, we will print the values. So, sorry. Now this value is printed before swapping. So this is before function, and this will be after function. After function. Now let's write a function swap for this. It is reading the values int a and the function has to return and here we will swap. The swap can be done in many ways. The simplest way is take some value as a temporary variable. It may be t. So temporarily keep the value in t. T is equal to a is equal to b, and b is equal to t. So this has to actually swap the values. If we want, we can print this also. Control V, print within the function. Within function, these are the values of a and b. So we will check that within the function they are exchanged or not. Now let's run this program, build and run this program. Let's put so before function a is 10, b is 20. Within function they are swapped, but after function they are not swapped. We know the reason, that the variables in the function, when they are transferred here, formal and actual parameters, they don't keep the values. Now here there is a solution that instead of sending the values, if we send here the addresses, and a and b become the addresses. Here it needs values. So star a, star b. So the main function is sending the addresses. Swap function is getting the values. And now these values are swapped. Now we don't need this within function also, or if you we will put it here star star b. So from main function the addresses are sent. In swap function the numbers are received. The numbers are exchanged also using the star, and then they are coming here back. Now let's run this. Before function a is 10, b is 20. Within function they are swapped. After function also they are swapped. Now here when the function is called and it comes back, we have got the swapping. So values keep their values within the functions when they are called if we send the addresses that is seen here. Now one more use of pointers is, in case of normal function only single value can be returned, but if we use pointers, two or more values also can be returned. That we will see here. Suppose we want sum of two numbers and say product of two numbers. So let us say a is equal to okay, a is 100 and b is suppose 20. Let it be, b is 20. Now we want multiplication and we want division also of both. Okay, so let us call the function. We want sum, addition, we can have addition and multiplication. Suppose sum pro, suppose sum pro, we want sum and we want product, so sum pro. This is the function which we will call. To the function we will send all the required variables. After the function we will print the values of sum and product. So printf sum is equal to %d \d, then product is equal to %d, and then we will put here sum and product, sum and product. So these two values will print. So we must define sum and product here, sum and product, both are different. Now all these variables we must send to the function. So here we will send, when the variables are sent, we have to send their addresses. So and a comma and b comma and sum and product. So and product all are sent here. Now here we have to write the function. This is the function. This function will receive all the values. It will receive int star a comma int star b comma int star. Now it is not necessary that you should keep the variable names same within the functions. You can have int star p. This is also allowed. So we have taken these values because anyway the addresses where the functions are where the variables are stored, they are different. Function has to return the value, so return 0. Whatever the value is returned by the function is not at all related to the calculations done in the function. Now we have to calculate this. We have to find out sum, we have to find out product. So star s is equal to star a plus star b, and we have to calculate product also. So star p is equal to star a star b star b. So star a and star b are multiplied here. Now star s and star p, they are generated and automatically they will be taken here. Now let's run this program. First build, if there are any errors, no errors. Now run. You can see sum is 120, product is 2000. Now you can see that sum and product, they are generated by the function and they are received by the main function. Two variables are got returned from the function to the main function because we have used the pointers. Okay, now let's do something else. Pointers are used in arrays also. So let's define some array. Let's define some array. Say int, integer array, initially suppose a, and let's put the values, any values of our choice. Suppose these are the values. So this is the array. Now we have to print the values of arrays. So we need some counter also. Let the counter be n. Let the counter be n. So n will be the count. Now normally how we print array is, this is our normal method. And because of pointer we will get one more method that will see n is equal to 0 to n less than 5 to n plus plus, and what we do is we just print it. And we want to print the address and as well as number. So a I is equal to, in case of I we have to write down %d is equal to, again here %d, and let's have \n. And here we have to put the values of I and a I. Now all the values will be printed. Let's run this. I is a, yes, I have used n here and I here. Let it be n. Build 0. Run. So A0, A1, A2, A3, A4, they are printed. Now suppose we want to know the addresses also. Then what we can do is we can use AND A operator, or we can define the pointer also. Now let's define a pointer. This pointer is for integers. So let us define integer star, and this is a pointer for array A. So let us give a convenient name as PA. PA is pointer for A, but you can give the name, any name of your choice, of course. Once you define a pointer, we must equate pointer to the address. Now see here, the address is and A. And A means what? Which address? Because A is having 5 values, so every address will be different. But when you say A, it is always the address of A0, that is the starting location. So PA is equated to starting location. Now let us print everything. Print address also and the values also. So let us print, suppose, so that we will understand how the values are printed. For the address, it has to be %u always. Then let's put some space. Now we have to put write down A. Then we have to write down AI. So for I %d, and After that we have to print the value also. So for value again %d. So all these we have to define as first is address, so PA, second is n because n is a counter, and third is value, value is star PA. Now see, PA is equated to only the starting address. So how to get the next address? In case of n, when you say n plus plus, normally n is incremented by 1. But in case of pointer, it does not always incremented by 1. If it is of character pointer, then it is incremented by 1. If it is integer, then depending upon how many bytes are required, that is incremented. If it is float, again according to bytes required, it is incremented. So PA++ if you write, it will not always incremented by 1. That we will immediately see when we run the program. So let's first check. Warning, assignment from incompatible pointer type. What is incompatible? Let me check. So after every value we have to go to next line. So let's put \n and let's run the program. See, address is this A0, the value is 12. Address is this 12, 16, 20, 24. What does it mean? These are integers. Every integer requires 4 bytes because it is 32-bit compiler. So 8, 9, 10, 11 will be used for this number. Then 12 to 16 for this, 16 to 20 for this. So whenever we have incremented PA, it is incremented by 4. And whenever we have incremented I, it is incremented by 1. That we can see. So pointer is incremented by the number of bytes for which it is designed. Okay. Now let's do something else. Pointer save memory. This can be proved using strings. So let us define array of strings. Let us define array of strings. So that will be, say, character array. Suppose some words we will have. Then let us say we have 5 words and each word may be up to 10. This is our normal way of defining character array, which we have already studied. Now here we have to give the values. We have to give the strings. So let's define some strings. Suppose hi. Then suppose hello. This is another. Suppose thank you. Thank you is one more. Suppose sorry. Is one more. And we need 5. So let us say good day. Good day is one more. So these are our strings. And this is the array of strings which we have defined. Now the way which we normally print this array is, we need a counter. So let us say int I as a counter. So for, we will check now. This is I less than 5. I need not explain this to you. I plus plus. We are printing this array along with their addresses. How to get address? With the AND variable. So let's print this. Printf. What we want to print? We want to print address. So I forget this, so I immediately give this \n. Address. Now for address, it is always %u. So we have to print the address. Then let's keep some space. Now we want to print this string. The string is %s. The string is %s. So address will be seen and the string will be seen. Now for the address, we must give and for the actual string, we don't need string. So and the name of manners, and we want first, second, third, that means 08, first, second, first, like that onwards. So this we want again the same here. So this is the actual string, this is address of string. This is our normal way without using pointer. So let's use this and check what are the addresses. So let's build it. Error. What is the error? Let me check. 4 number line. This is the error. Okay. Again build. No error. Now let's run this. So addresses are this, and hi, hello, thank you, sorry, good day is this. You can check the addresses. I expand this for you. The addresses are 63566 is common, 82, 92, 702, 712, 72, 722. That means 10 bytes every time. Because why? Because we have defined this as 10. So whatever is the length of the string, always it takes 10 bytes for this. So when there are 50 bytes are there allocated in the memory for this. If we use pointers, then this will be reduced. See how? I keep this as it is and let's use the same thing using the pointer. So let's define one more array. This is an array of pointers. When it is an array of pointers, put star, give name, suppose words. Words is the name of array. Now you need not specify the space because space is automatically allocated. Now here the same string I will use. Same string I will use. For the same string, how the addresses are allocated, that we will see now. The same string we will print. So we need this as it is. Here also. And now we need a print statement. In the print statement, I will write address, then %u for address, then t, then this is for string, and now the name is different. Now consider that this is pointer. So star words is the value and words means address. Here it was different, and mean address and without and is value. Now here without star is address and with star is value. So what we have to write is words I, this will be the address, and now comma star, this will be the value. Okay. Now it is expected that same will be there, but the difference is the addresses, how they come. Error in the 9th bracket. Yes. It has to be error free for running. Yes, no errors. Now let's run. It is not printed at all. Let me check. Yes, address is word size, and word size when it is given through %u, it gives the address, and the same when it gives %s, it gives the string. Now let's run this. um, let's run this again. I must give some space in between. So let's, after this printf, I keep some space here, \n. So there will be one line in between. Otherwise there is a confusion, a lot of confusion. Okay, so this. Now let's compile and run this. Run. Now observe carefully. I expand this for you. Address here 10, 10, 10 differences. But here, high 45, 46, 47 and 48. We know that in case of every string, the last letter, in case of every array, or by the way, backslash 0 is the last. So backslash 0 ends in every string. So 45, 46 will be for H and I, 47 for backslash 0. Again here 5, so 6 are there, 6 addresses are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, so 54 to 64, 10 are required. Again here there are 5, so 6 are required. So in this way, whatever are the required characters, only those memory locations are allocated. So difference of 45 to 70, you can check 70 plus whatever is this, and here complete 50 are required. So in this way, the pointers can save memory. For only 5 statements, this difference may be less, but when you have a lot of data with lot of statements, lot of variables, then this causes a considerable saving of memory because of pointers. Okay.